Now we're going to talk about an important idea, probability, mutually exclusive event. Two events are mutually exclusive if they cannot happen at the same time. In probability terms, we say that if A and B are mutually exclusive, then the probability of A intercept B equal to zero. This means that the two events have no outcome in common. In the Venn diagram on the right, you can see how we illustrate this. A and B have no overlapping areas. Now, let's go through some real-life examples to understand this better. First example, can you be asleep and awake at the same time? No, these are mutually exclusive. You cannot be asleep and awake at the same time. Second one, is there rain and sunshine at the same time? Sometimes it rains, and sometimes the sun is also shining at the same time, and that's how we get rainbows. So yes, they can happen together, and therefore these are not mutually exclusive. Third example, turning left or right attention. These are mutually exclusive. You either turn left or you turn right. You can't do both at the same time. Passing or failing on the test is mutually exclusive. You either pass or you fail. You both cannot happen in the same attempt. Can you be at home and at school at the same time? No, this is not physically possible. So this is mutually exclusive. Can you get an even or odd number on the dice? Yes, these are mutually exclusive. The number of the dice is either even or odd. It can never be both. To summarize, mutually exclusive events are events that do not overlap. Only one happen at a time. If they were to happen both together, it will be impossible. And that's why the possibility, in other words, the probability of that happening together is zero. Two events, A and B, are called mutually exclusive if they cannot happen at the same time. In mathematical terms, this means that probability of event A intersecting with event B equal to zero, meaning they have no outcomes common. Now let's look at some math-based example to have a better understanding of what is a mutually exclusive event. Event 1, coin toss. Event A is getting a head, event B is getting a tail. Now ask yourself, can both happen in one toss of a coin? The answer is no. A coin can only land on one side at a time. So A and B are mutually exclusive. Example 2, rolling a dice. Rolling a 1 and rolling a 4 can both happen in one row of a standard 6 standard dice. Again, no. A dice can only land on one number in a single row. So these events are mutually exclusive. Example 3, drawing a card. Event A, drawing a king. Event B, drawing a red card. Now let's think carefully. Are there any red cards in the standard deck of cards? Yes, the king of hearts and the king of diamonds are both red. So it's possible to draw a card that is both a king and a red. That means A and B are not mutually exclusive because they can occur together. If two events can happen together, then they are not mutually exclusive. Now we are going to learn the important formula used when we are dealing with mutually exclusive events in probability. What does mutually exclusive means? We didn't know that two events A and B are mutually exclusive if they cannot happen at the same time. In mathematical terms, probability of event A intersect with event B equal to zero, meaning they have no outcome in common. Now here's the key formula. If A and B are mutually exclusive, then probability of event A union with event B will be equal to probability of event A plus the probability of event B. This means the probability of A or B happening is simply the sum of the individual probabilities. Example, if a dice is tossed, what's the probability of rolling a 1 or the 4? Let's define the event. Event A is throwing a 1. We know that probability of event A equal to 1 over 6. Similarly, for event B, throwing a 4, the probability of event B is equal to 1 over 6 as well. Can both a 1 and a 4 occur on the same roll of a dice? No. We know that a dice can only show one number at a time. So these two events are mutually exclusive. Therefore, we can apply the formula to get probability of rolling a 1 or rolling a 4 equal to the probability of rolling a 1 plus the probability of rolling a 4. We give you 1 over 6 plus 1 over 6, which gives you 1/3. Therefore, the probability of rolling a 1 or a 4 is 1/3. To summarize, we should use this formula only when A and B are mutually exclusive events. We have to check that the events cannot happen at the same time, and if so, we can simply add these two probabilities together. Now let's go through a more fun example while we a party game. In a party game, Maya picks a balloon at random from a basket. The basket has 3 balloons, red, blue, or green. Then she spins a color wheel. The spinner has 4 equal sections, red, blue, yellow, or black. Each balloon has an equal chance of being picked, and each color on the wheel has an equal chance of being landed on. There are 4 probability questions that you can answer. My hint to you here is to use a tree diagram. To do this clearly, let's use a tree diagram. We start with the 3 balloon color, red, blue, and green. For each balloon, the spinner can land on red, blue, yellow, black. So we pair each balloon with each spinner color, and let's list all of them. We have red, 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 blue, red, yellow, red, black, blue, red, blue, 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 yellow, blue, black, green, red, green, blue, green, yellow, and green, black. This gives us a total of 12 total outcomes in the sample space. Now we can answer each of the questions by counting how many of the outcomes actually match. A. What's the possibility that the balloon and the wheel both show red? We look at the list, we see that there's only one outcome, only red, red matches. So the answer will be 1 over 12. For B, what's the probability that the balloon and wheel both show blue? Similarly, from our list, only blue, blue matches. Therefore, the answer is 1 over 12. C. What is the probability that the balloon and the wheel are both red or blue? In this case, for the first two questions, we already have found that there's one outcome of red, red, and one outcome of blue, blue. We can add them together because they are mutually exclusive events. So probability of red, red, and blue, blue will be 1 over 12 plus 1 over 12 equal to 1 over 6. Last one, what's the probability that the balloons and the wheel show different colors? Let's count how many outcomes show the same color. We have red, red, and blue, blue, which is 2 outcomes. So the remaining outcome must be where the colors are different. We can simply use 1 minus 1 over 6 to give you 5 over 6. To summarize, we have used a tree diagram to list all possible combinations. We counted how many outcome matches what the question asked, and then we divide the numbers by the total number of outcomes, which was 12. This method works very well when the number of outcomes is small and easy to list down.